Hi guys, Rao this side, and welcome to Creatrix channel. Subscribe to our channel also, that is Gate Conqueror channel. Anyway, the purpose of this, at the end of this discussion, you are going to get the clarity about four interview questions. That is, first of all, homopolar, heteropolar. In our commercial machines, we never use homopolar. Always we use n pole, s pole, n pole, s pole, n pole, s pole, that way. Means all n's we are not going to maintain. Why? Okay. Always in machines you have to understand one thing. That is like kind of machines is kind of lakhs of rupees or crores of rupees. So means commercialization should happen to the machine, meaning that our design should be of less cost. Okay, that is our primary thing, and operation should be of less cost. That is the primary thing for us. And while solving interview questions also, like some questions we can discuss once we start electrical machines only. Okay, as of now, outline of electrical machines, four interview questions I'm trying to solve. Okay, now why can't we use homopolar machine in practice? Though at the scientist level it is available, okay, but in order to convert that particular invention to practical, okay, economization matters, okay, optimization matters, cost matters, because our machines are not poised to play. And one more thing is, while solving the interview questions, while answering the interview questions, like with only equations, it will not work out. Okay, we have to understand the practical approach of the machine, rather than writing equations, formulas, and all. Then only we have done so. Now, next thing is, what is the costliest part of the machine and how it changes the design. Okay, again related to money, design. Okay, so manufacturing cost. And why can't we use toroidal core in transformer? Normally, cores of the transformers will be like this. Cores of the transformers cannot be like this, toroidal cores. Why can't it have toroidal core? And what is electric shock? What is electric shock? You might feel that electric shock can be felt, cannot be explained. It is not like that. What is electric shock? They will ask. And before starting anything, let me share details about myself. I'm Rao. And I got by gate 2021, I completed 20 years of training in this particular gate RSC field, and obviously I should got at least more than 1 lakh students. And I too got different PSUs and all, but it's of irrelevant as of now. See here, subjects taken electrical machine, network theory, and I will try to take power systems also. And if you want me to be motivated to release such a kind of videos and all, I request all of you to subscribe to Gate Conqueror YouTube channel. Okay, and if you want me to guide you personally, use my code KNR10. You will get 10% discount also. And there are two kinds of platforms in Unacademy, paid platforms. One is Plus and another one is Iconic. In Plus, you are going to get live classes, crash courses, rank improvement batches, and kind of doubt discussions. Okay, doubt solving, rank improvement batches, and they will discuss both in English and Hindi. Okay. And here, if you think of Iconic, which is superset, means whatever is available in place, everything will be available. Beyond that, you are going to get a personal coach of your age. Because if you directly contact me, with me, you may not be able to discuss each and everything because of the age gap. Of your age, who is an achiever, will be allocated to you as a personal coach, who will help you in planning your study, and who will help you in personalized test analysis, because it is very much important. Critical test analysis has to be done, then only you will come to know in which portion of the subject you are weak and all. And also materials they are going to provide. And for plus 27,000 to 25 for 12 months, and 34,650 for 18 months, and 39,600 for 24 months for plus subscription. If you think of Iconic, for 12 months it is going to 40,500, and for 2 years it is going to be 54,000, and some no cost EMI facilities also there. And they thought of increasing the fee structure from July 1st onwards, but they postponed the decision because of huge demand from the student community. At any point of time, they can increase the fee structure. So if you want to subscribe, because we don't have much time also for the gate preparation, if you want to subscribe soon to the paid platform. And see, Spark and Vero batches. Spark batch is meant for gate 2022, and Vero batch is meant for gate 2023. This is directly English speaking only. Okay. And I'm going to start my machines. And with all of them, I worked. Vishnu sir, I worked. Achikamal sir, I worked. Suresh sir, I worked. Trinath Reddy sir, I worked. BV Reddy sir, I worked. Somehow I missed Bhem Shankar sir working with him. And signals and systems, Vishnu sir is about to start. And Lakshya batch and Arhan batch, it's kind of English or Hindi batches. Lakshya batch is meant for Gator ESC 2022. Arhan batch is meant for Gator ESC 2023. And again, obviously, best faculties, top best faculties of India are working with Unacademy as of now. And about test series, they are providing for the paid platform. They are providing huge test series also. Kind of Accelerate, Elevate, Excel, Accord. Many test series are available. If you want to follow me, kindly follow me here, Rao for you in Unacademy platform, such that whenever I come to special classes or plus classes, you will get the notifications and all. You can follow my lectures and all. Yes. Now interview questions. First of all, answering interview questions, I told you, right? We have to have better understanding of the practice. Then only you will be able to answer these questions. Okay. Now, let us start with electric shock. Electric shock. Can we explain it? Yes, we can explain it. Okay. See here, let me tell you the statement first. Any external electromagnetic signal which interferes communication channel of the body is nothing but electric shock. I repeat, external electromagnetic signal which interferes completely with the communication channel of the body is nothing but electric shock. For example, see this hand. I am raising my hand. I am dropping my hand. I am raising my hand. I am dropping my hand. So for this hand, who is giving signals? Brain is giving signals, right? So means my brain is sending some signal to my hand to raise, to drop, to talk. How it is happening? Through some electromagnetic signal only. My brain will send to my hand electromagnetic signal, above raise, above drop. Getting my point, right? Now any other external signal which completely interferes with communication channel. For example, if this is the live wire, okay? If I touch the live wire, then what will happen? Means don't think that kiloamperes of current should flow through the body. It is not like that. Milliamperes of current is enough to make you feel the shock. Okay? So the moment you touch any live wire, immediately what is going to happen? This external electromagnetic signal will start passing through me. If I'm standing on earth barefooted, okay, then this electromagnetic signal will flow through me to the earth. Now, the moment any external signal is flowing, even though my brain send a communication signal to this hand saying that, hey, idiot, just leave. That particular signal should be received by this, not to leave. That particular signal should be received by this hand to leave. But that particular signal will be completely distracted because external electromagnetic signal is completely interfering the communication channel. When I was in diploma, my grandmom used to say this, like, don't go near to electricity, it will attract you. It will not attract actually, but it will not leave you once you touch. Because you are going to lose control of your body because of that external electromagnetic signals. Okay, so the moment I close my hand to the live wire, then immediately I am going to lose my control of my hand. Even though brain will keep on pump signals, just I cannot open this. Because that signal is completely distracted and that signal is not being received by this. Okay. Now, next thing is, previously, when insulations, these much grade of insulations were not developed, at that time, people used to say that don't work with two hands. Why? If you are working with two hands, if at all, if you get shock or electrocuted, you understood, right? At the same time, previously, means as operating engineers, maybe 40, 50 years back, till that point, as operating engineers, only right-handed people used to recruit. Why? Because right-handed, if you work with right hand, safe. Okay. If you work with left hand, dangerous. Okay. So anyway, we understood about electric shock. What is that? Any external electromagnetic signal which interferes completely communicate channel of the body. is nothing but electric shock. Okay. Now let us think of next question. Why can't we use toroidal core in transformer? Machines are not toys to play with, because machines are supposed to transform megawatts of power. Okay, so the moment they are transforming megawatts of power, obviously the cost of the machine will be in crores or lakhs. Okay, so the moment the price is lakhs or crores, obviously you cannot play with. They are not toys to play with. Okay, now always we will try to reduce the design cost of the machine, operating cost of the machine. Always we should think like entrepreneurs, okay, economists, such that we have to try to economize, because maybe in the what they say scientists may develop some inventions and all, but those inventions will come to practice only if you can be able to economize the things. Okay, most of the all these four questions are related to that only. Now why can't we make toroidal core, meaning that this is going to be toroidal core. This is going to be toroidal core. Our square core or rectangular core, which we use in transformer, is nothing but this. We are going to use such kind of core. And don't get confused with area of cross section of the core. Area of cross section of the core, if I cut it and see here, it can be square also, or it can be circle also. Or if I cut it and see here, it can be circle also, it can be square also. It's a different thing. Okay, kind of see here. This is core. This is core. If I cut it and see, area of cross section of the core is going to be a circle. Okay, so there are of course some reasons are there to make it as nearer as possible towards circle. It's a different story, stepped core and all. We will see later, because few things we have to understand, then only we can discuss such kind of questions and all. Now see here, this is the core, right? If I cut the core, area of cross section of the core is what they say circle. Similarly, here also such a kind of core I can make it around. You understood, right? Now, first of all, let us see how, okay, it's fine. Okay, let us see, this can be circle or this can be square, or this can be circle or this can be square. How, what is the process of manufacturing a transformer if you see? Okay, maybe if we see windings, we may think of windings are going to be like this, right? Windings are going to be like this, or windings, why can't windings will be like this? Because in +1 or +2, when we are studying magnetism, electromagnetism, means most of the maybe kind of most of the science books might have given this kind of thing, but in our transformer we are going to have this only. Okay, this is called toroidal core. Toroidal core. This is called square core or rectangular, whatever it might be. Now, basically, how machine is being manufactured, how transformer is being manufactured, if you see, first of all, windings will be manufactured. See here, don't think that this is the core and one guy will be there. That guy will take the wire and keep it round like that. It is not like that. Okay, because it has to deal with huge power. Okay, what we are going to do is, first of all, we are going to pre-form the windings. First of all, windings will be formed. Okay, windings will be formed. Windings will be formed. And then, of course, you are going to get very soon. Okay, and after that, windings are going to be taped. Okay, let me write here. Windings are pre-formed, then taped, taping is done, then insulated, and then placed at required location. Placed at required location. In the sense, windings are going to be formed first. For example, I am the core. Okay, first of all, windings will be formed. Windings will be formed, and taping will be done. And we are going to pour insulating material and all. Then this particular thing means on the core, no, this particular windings will be kept on top of me. You understood, right? So in order to push those windings, obviously circle cannot work out. Getting my point, right? So first of all, windings are preformed, then taped, then insulated, then it will be placed. Not only in our transformer, in all machines, because insulation design is more crucial. Okay, about that we'll see later. So means if it is having straight like this, then windings are going to be formed, and then inside lamination by lamination we can insert. Okay, so windings are like this. For example, windings are like this. Then lamination by lamination we are going to insert, and we are going to. You understood, right? Now, if it is like this, definitely once windings are formed, one by one lamination we can insert and we can tie. But if it is like this, how to insert the laminations inside? Not possible. Not possible. That's why means answer for this question is very simple. Windings are basically preformed, taped, insulated, and then placed at required location. Now, inserting the laminations here is means it's not possible, obviously. Okay, because it is having the bend, it is having straight. You understand my point, right? So that is the answer for this. Now, what is the costliest part of machine and how it changes the design of whole machines? To understand this, we have to understand the difference between machines and measuring instruments. Of course, I don't want to discuss much about it, okay? But I'll give you a simple idea. Machines, very big machines, okay? Measuring instruments are small. Of course, both are going to be operating on the same principles, okay? Measuring instrument and our machine are going to work on the same, but the target is going to be different. Machine, very huge, is going to transform bulk of power. If you think of measuring instrument, it will transfer information. Okay, measuring instrument will give you, for example, if you think of ammeter will not continuously rotate for hours together or months together or years together. But our alternator will work continuously. You understand my point, right? So measuring instrument, it is going to transform information. It is going to show you whether it is 5 amperes or 10 amperes or 2 amperes. But if you think of our machine, it is going to transform power. Basically, depending upon this, many interview questions can be solved, but some background of machine knowledge is required. That's why I'm not discussing. If you think of lamination, why do we laminate? We say that to reduce eddy current losses. No. In machine, to reduce eddy current losses, in measuring instruments, to reduce time constant, we say. Time constant, big logic, forget about it. Now, anyway, the costliest part of machine is shaft. Okay, in order to reduce price tag of the machine, length of the shaft has to be reduced. In order to reduce length of the shaft, already we know that means power handling capacity of any machine is nothing but the air, volume of air which is there in between stator and rotor. This is related to obviously rotating machine because shaft is there. Okay, so power handling capacity of any machine can be decided by volume of air in the area. Okay, that's why high rated machine area will be more, low rated machine area will be less. Forget about it. Anyway, length of the shaft has to be reduced, but volume of the air should be more. Then what we are supposed to do? For example, see here, this is length of the shaft. Okay, now you can see your ceiling fan, and then automatically you will understand things. Okay, this is the length of the shaft, and here, this is the core, rotor core. On top of that, stator is there. Okay, what about the volume of air here? In order to maintain the same volume of air and in order to reduce the length of the shaft, what has to be done? For example, length of the shaft, and let us increase rotor. Okay, such that diameter of the rotor let us increase, and this is kind of stator. Okay, now check your ceiling fan. Your ceiling fan length of the shaft, okay, or means linear length. Okay, length of the shaft is going to be much less, but diameter is going to be more. Now, in order to reduce price tag of the machine, but of course, time constant problem will come. But our machines are meant for example, if you switch on your fan, will you play with it like on off? You're not going to play with it, right? You are going to switch on and relax. Maybe for hours together, overnight, or maybe complete day, or maybe complete one day. Okay. Similarly, our machines are meant to transform bulk of power, huge of power, megawatts of power. Okay, in steady conditions. In the sense, for days together or weeks together or months together, they are supposed to rotate in the same condition. Okay, kind of our alternator and all. Anyway, point here is to reduce length of the shaft, costliest part of the machine. Why that shaft is costliest part is kind of hot forging, cold forging methodologies that is related to mechanical engineering. We need not bother. Okay, but what we have to do is, yes, shaft is the length of shaft is the costliest part. In order to reduce length of the shaft, we increase diameter of the rotor. We have to say we increase the diameter of the rotor in machines. In machines, measuring instruments contraction will happen. We will see later about that contraction. Okay, so shaft length will be reduced, diameter of the rotor will be increased, diameter of the rotor will be increased such that price tag can be reduced. Okay, now next thing is, why can't we have homopolar machine? Okay, see here on that means answer is very simple. That is back to back connection. That's it. Okay, now let me tell you, if I have N pole here, if I have S pole here, just like that, wait. Cool. Now, this is stator, for example. In the rotor, if I have one conductor here, if I have another conductor here, okay. So this is at the, already I'm expecting few things should be known by you. Anyway, gradually once plus course is started, automatically you will come to know. Okay, this is back to back connection. For example, if it is rotating, here in this direction, if voltage is induced, as it is on N pole, in this direction voltage is induced, will be induced as it is south pole, right? So N pole in this direction voltage is induced, S pole in this direction voltage is induced, such that this plus this is going to be here. If I think of this conductor voltage is E, this conductor voltage is E, here you are going to get voltage of 2E. Why? Because of this is called as back to back connection. Okay. Now, if you see commercial motors, of course, homopolar motors are available, but for just to showcase to kids. Okay, just to showcase to kids that okay, one battery kind of one permanent magnet and one wire it is going to rotate. It's okay, but at small level, you cannot build kind of huge level power handling capacity in the homopolar structure only because of lack of back-to-back connection. Try to focus properly because we have to understand this. Okay, then only the importance of heteropolar. Okay, all of our commercial machines are heteropolar just because of lack of back-to-back connection. That's the reality. That's the reality. Okay, see here. This is stator. Okay, gradually you'll understand. Stay tuned. Gradually you'll understand. Okay. Now this is stator. Red is stator, and blue is rotor. Blue is rotor. Okay. Gradually you understand. Gradually you understand. And upon that I am going to have conductor. Upon that I am going to have conductor. Okay. Let me explain with cross-sectional view. If I can explain with cross-sectional view, definitely you will understand. Where is this here? All red are stator only. Okay, you will understand now. This is stator. Just a minute. This is stator. Everything is stator. This is stator. Okay, you will understand. Just relax. Okay, Sai, glass over this one. Biting one. Okay, just you will understand. Now let me think of rotor. Rotor is like this, and rotor conductors will be like this. Okay, see here, structure is going to be, this is glass, right? So structure is going to be like this. This structure is going to be like this. Inside, Okay, see here, stator structure is going to be like this, or stator structure is going to be like this. Okay, so this is at the center, red. On top of that, this is going to be my glass. This is going to be my glass, such that it is going to be like this. You understood, right? Let me try. See here, this is going to be this. This is going to be this. Inside shaft is not shaft, it is also stator. Okay, so this is going to be stator. This is going to be red, or this is going to be red. See here, this is my hand. This is my center part. Okay, this is going to be like this. You're getting my point, right? So this complete red stator is this. Inside stator is going to be like this. Completely stator only, it will be attached to here. It will be attached to here. Now, let us start with the pole structure. Let us start with the pole structure. What I'm going to have is N pole here, N pole here, S pole here, S pole here. Such that my flux will come from N pole to S pole, and here it will go back. Flux path is formed. N pole to S pole here, and it is going to go like this. Okay, everywhere the same. Meaning that just wait, you will understand. N pole, everywhere N pole only, everywhere N pole only, everywhere this is going to be S pole only. S pole only. Stay tuned. Relax. From N to S, flux will go. From N to S, flux will go. N to S, flux will go. N to S, flux will go. Getting my point, right? In the sense, kind of, this is my stator, right? This is my stator. Everywhere I am going to have N pole only. Everywhere, see here. Everywhere, round, see here. Everywhere I am going to have N pole only. Okay? So, this is the structure, no? So, if I cut it, it will be like this only, no? Everywhere N pole. Everywhere N pole. At the center. This is also, like, center one is also kind of, stator only. So, this particular thing, everywhere around this, it is going to be S pole. Okay? Everywhere around this is going to be S pole. Maybe this is better. Okay? So, everywhere it is going to be S pole. Everywhere it is going to be N pole. So, this is stick like this. This is stick like this. Such that, see here, everywhere outside N pole will be there. Everywhere on top of this S pole will be there. N to S flux will go. Okay? This is better, I think. So if you see this glass, inside of the glass, it is going to be N pole. And outside of this particular thing, this is also kind of stator only. Outside of this particular thing is going to be S pole. And here, this is stator. Getting a point, right? So this is going to be stator. Or if you cut it, this is going to be the stator. Right? Now, everything is stator, no? Now let us consider this. Now let me have, means if I think of this is the center one, let me have on top of this. Okay? Let me have on top of this blue one, rotor. Let me have this blue one on top of this. Let it rotate like this. Okay? So we can assume kind of one bucket here, and bucket can be rotated, no, by shaft. Okay? So this is going to be kind of, if I keep one bucket here, okay, so if this is the shaft, this is the stator, center stator. On top of that, we are going to have rotor, and these fingers are my electrical conductors. You have to bear, because it's an interview question. Okay, so these conductors are my fingers are my electrical conductors. Let electrical conductors rotate. Now observe. See here N pole, and here S pole. So N to S flux is coming. Okay, here also N to S flux is coming. Here also N to S, everywhere flux is coming and going like this. So flux is coming here and going like this. Okay, so everywhere from N pole flux is coming towards the center part, which is stator. Flux is coming here, which will go inside and come back like this. Now, if I keep my conductors like this, blue, and if I rotate my electrical conductors, everywhere my conductor is going to see N pole only. Everywhere my conductor is going to face the N pole only. Okay, meaning that pure DC you can generate. What do you say? Pure DC voltage can be generated, because means in each and every conductor. For example, if I think of my induced voltage here is positive. Here also, in this also, induced voltage will be positive, negative one, because if this is under N pole, this is also under N pole only. Okay? Try to visualize, very simple. This is stator. This is stator. This is stator. Okay? So, inside the stator, it is going to be rotating. Okay? This finger is stator. Everywhere N pole. At the center, everywhere S pole. On top of this, it is going to rotate like this. It is going to rotate like this. These fingers are electrical conductors. Hope you got the visualization. Okay? Now, this is going to be the case. Now, if I get plus voltage, minus voltage here also I am going to get plus voltage, minus voltage only. Pure DC. You need not have commutator now in order to generate DC voltage. Okay? So, directly DC is going to be generated. Because in DC generator, AC will be generated, that AC will be converted into DC by commutator. But commutator is not required now. But there are many problems. Basically, we need everything at economized price. Okay? Means just to have DC, I cannot take, so much, I cannot invest so much of money because these are all commercial machines. They are not meant for scientists. Right? We are not scientists. We are economists. We are entrepreneurs. Now, see here, this is the case. Okay, here. Maybe in this case, let me take 5 volts is being generated here. 5 volts is being generated here. You have to focus here, please. If 5 volts is being generated here, 5 volts is being generated here. Now, if I take up the voltage from here, how much will be the voltage? Now you will understand the importance, because till now you might feel, okay, this conductor back-to-back connection. No, back-to-back connection decided the complete machine's future. Simple back-to-back. Okay? Now, see here. If I take kind of back-to-back connection here, here plus minus voltage is in use, minus plus voltage is in use, it will become 0 volts. It will not work out. Forget about it. Now, focus. For example, if I take output here, and if I connect these two, and if I take output here, how much will be the voltage from here to here? How much will be the voltage from here to here? How much will be the voltage from here to here? Is going to be, you may think that voltage rise, minus to plus voltage rise of 5 volts. Voltage rise of 5 volts, it is going to be 10 volts. No, it cannot be. Because this particular wire also is in the active region only, no? Okay, so this particular wire also is in the active region only, or kind of under NS poles only. Now, the moment you are rotating, in this also voltage, plus minus voltage will be used. Let me assume that voltage is 5 volts. Because it will be reduced a bit, but anyway, let me assume. Then how much it will be? Minus to plus voltage rise, plus to minus voltage drop, minus to plus voltage rise. You are not going to get 10 volts again, you are going to get 5 volts only. Our thing is, we want kilovolts, or at least 100 volts, significant voltage, 100 volts at least. Okay, with 5 volts, what can you do? Now, let us think of, this is not possible. Let me do it externally. Then you will understand. Okay, so maybe black, red. Okay, let me use pink, I think. Okay, now let me, in this particular shaft will be there, no? This is shaft. Okay, now let me have a brush here. Okay, kind of slip ring and brush. Let me have slip ring and brush. Now let me connect this to here. And let me connect this to here. Such that externally you can connect them in series. No, 5 plus 5 can be 10 volts. Externally, because once you bring those particular voltages to outside, outside external to the machine, you can connect them in series. Okay, you can connect them in series, just relax, you would enjoy, Okay, now externally, if I connect them in series, how much voltage I'm going to get? Will I get 5 plus 5 10? No. 5 plus 5 10 minus at least 4, it will be 6 volts. Because in DC machines, brush contact drop will be there. Brush contact drop, you are going to detect 1 volt. For example, in DC generator, if it is producing 200 volts, 2 brushes, 200 minus 2 is going to be 198 volts. The moment internal voltage is more, because of back-to-back connection, also you will get. Okay, so the moment internal voltage is more, you are not considering brush drop at all, brush contact drop at all. But if you think of 5 volts, 1 volt for brush contact, 1 volt for brush contact, 1 volt for brush contact, 1 volt for brush contact. So significant amount of voltage drop is going to happen across the brushes. Significant amount of voltage is going to be dropped across the brushes. Again, it is going to be output voltage is going to be much less. Now, with this, okay, 2 conductors, I have 6 volts. For 2 conductors, I need to maintain 4 slip rings and brush contact. For example, if I want to maintain this to 600 volts, okay, then for 2 conductors means into 100. For 2 conductors, I am able to get 6. So I need to have 200 conductors. For two conductors, I got 4. For 200 conductors, I need to have 400 slip rings and brush contacts. 400. How much will be the length of the shaft? Kilometers wise, right? So point here is very simple. Homopolar structure is available to do. But if you see from cost point of view, length of the shaft point of view, length of the shaft will be in meters or kilometers, which will increase the cost of the machine. Getting my point, right? So with homopolar, the disadvantage is significant amount of voltage cannot be taken. So commercially it is. But if you think of heteropolar, just like that. If I think of heteropolar, let me take only 2 poles. What's the big deal? Our DC generator only kind of stator, going to disturb. Stator, black is stator. Now let me have one wire like this. And here, let me have back-to-back connection. This is active length. For example, here plus minus 5 volts is in use. Here, opposite to that has to be in use. Because this is under N pole, this is under S pole, center of the S pole, so this is going to be plus minus 5 volts. How much will be the voltage here? Voltage here is going to be 10 volts. For example, if I want 600 volts from here, in order to tap this voltage, how many brushes are required? 2 brushes can be, 2 brushes, yes. For example, if I want 600 volts, then what I can do, let me have back-to-back connection. Again, back-to-back connection. Again, back-to-back connection. In that way, if I maintain 60 turns, again, how many terminals are going to come out? Only 2 with 2 brushes, means 60 turns into 10 volts. Directly is going to be 600 volts. Maybe if you want to take the voltage drop for 2 brushes, okay. So point is very simple. In order to produce significant amount of voltage, homopolar is not possible. At least 100 volts. But significant amount of voltages can be produced in heteropolar, heteropolar structure. Significant amount of voltage can be just like that. It can be produced because of back-to-back connection. Okay, so simple. Our back-to-back connection decided that all commercial machines should be of heteropolar structure. Otherwise, you would have got homopolar also maybe. Okay, and in homopolar, because of lack of back-to-back connection, significant amount of voltages cannot be achieved. Even without the back-to-back connection, if you want to achieve significant amount of voltages, length of the shaft should be so high. Number of brush rigs should be so high. Number of slipping should be so high. That's the thing. So commercially, it's not possible. Thank you guys. Thank you very much. In the next interview session, I'll bring, and as a comments, you please specify your interview questions such that I will add that also, and I'll continue my remaining interview questions also. But kindly subscribe to Gate Conqueror channel. Okay. Thank you guys. Thank you very much.